Today I discuss one important topics, the area of a parallelogram. Okay, the area of a parallelogram. Understood? We discuss these topics today. We here write the angle between two vectors. Okay, we start from this one. That means the angle between two vectors with measure theta. Okay, angle between two vectors in R square. Two vectors in R square. Okay, with measure theta. With measure theta equal to 0 less than equal to theta less than equal to pi or less than pi. Okay, that is formed by the vectors having same magnitude and direction. Okay, mm, is formed by the vector is formed by the vectors, okay, having same magnitude and direction, having same magnitude and direction. Okay, as the given vectors and as the given vectors. Okay, emanating from origin. Okay, then what happen is here beta equal to uv is an order basis for R square. Okay, then we define the orientation of beta to be the real number. Okay, we define the orientation of beta, okay, to be the real number. Here orientation of uv equal to date uv by mod of date uv. Okay, then what happened is here we write it in this way. This orientation clearly, this orientation of uv equal to plus minus 1. Okay, then we also write in this way. We use that portion and going to further discussion of that. Here notice that, okay, orientation of e1 e2 equal to 1 and orientation of e1 minus e2 equal to minus 1. Okay, then a coordinate, system, a coordinate system, okay, uv is called right-handed, is called right-handed if U can be rotated in a counterclockwise direction, if U can be rotated in a counterclockwise direction, okay, counterclockwise direction through an angle theta, through an angle theta as 0 less than equal to theta less than pi, okay, or 0 less than theta less than pi. That means a coordinate system UV is called right-handed if U can be rotated in a counterclockwise direction through an angle theta, okay, to, to coincide with P, to coincide with P, okay. That means here also write it in this way, this one, okay, this one X, this one Y, okay, and here this one U, this one V, okay, counterclockwise a right-handed coordinate system. This one is what? A right-handed coordinate system, right-handed coordinate system. And obviously that means this one, otherwise UV is called a left-handed system. That means U can be rotated in a clockwise direction, okay, through an angle theta. Then this one have what? To coincide with, that means this one is, we write it in this way, a right-handed, a right-handed coordinate system, okay, coordinate system. Then we also then discuss this one. Here orientation of UV equal to 1, okay, orientation of UV is equal to 1, okay, and that means when this one is, that means 1 means UV are linearly dependent, okay, this one happen, then if UV are linearly dependent, okay, understood? I think not a problem at all. And then now we also discuss in this way, that means this one, when this one is left-handed, left-handed, left-handed means just clockwise direction, okay, then that means this one is left-handed. How this one is changed, okay, we write it in this way, this one is V, this one is U, okay. Then we also discuss this one is, that means if this one equal to -1, okay, orientation equal to -1 and U here linearly dependent, then this one is left-handed, okay. So any order set UV in R square determines a parallelogram. So we now erase that portion and going to further discussion of that, okay. This one, what? Any order set, any order set UV, okay, UV in R square, in R square determines what? A parallelogram, determines a parallelogram, okay. And UV emanating from origin called the parallelogram having UV at, that means adjacent side, that means a parallelogram with adjacent side, with adjacent sides u and v. Okay. Mm, with adjacent side u and v, these two vectors. Okay. Then we also talk about that if this u v are parallel. Okay. Then the set is linearly, that means here linearly dependent. Okay. Then then the parallelogram determined by actually a line segment. Okay. Then we consider to be a degenerated parallelogram having area 0. That means if the set UVR, if UV are dependent, then what happens? Then the parallelogram determined by U and V, if U and V are linearly dependent. Okay. Then what happens? Then parallelogram determined by parallelogram determined by U and V, okay, is actually a line segment, is actually a line segment. Then what happened? Then that means we considered, which we consider to be a degenerated, to be a degenerate polynomial, having area 0, having area 0. Okay, understood? I think not a problem at all. Then what happened? Then we also discuss here one interesting relationship. We erase that portion and going to further discussion of that. Here we discuss, that means AUV. Okay, the area of the parallelogram determined by the area of the parallelogram, okay, determined by U and V, determined by U and V. Okay, then what happened? And now we also write it in this way. That means AUV equal to what? AUV equal to orientation of UV, here date of UV. Okay, since date of UV is negative, so area we write it in this way, it can't be negative, so we adjust it with orientation of UV. Okay, so we talk about this one, area of UV, area of parallelogram with the whose sides are UV. This one is this one. Okay, date of UV mod. Then what happened? We also write it in this way. That means orientation of UV equal to what? Plus minus 1. Okay, then we also multiplied both sides by the desired equation by this orientation. We write it in this way. Okay, AUV equal to this one. Okay, so now we also going to discussion about that. That means orientation of UV, area of UV equal to rate of UV. Okay, this implies. Then what happened? Then we also, this one we denoted it in this way, delta UV. Okay, delta UV. Then this one obviously we write it in this way, delta UV. Okay, so delta UV, we this one equal to orientation of UV multiplied by area, um, area of atoms contained by U and V. So area of parallelogram contained by the adjacent side UV. Okay, so now we discuss it another way. We write it, and then we have to show this one, these factors. We erase that portion and show another factor about that. Okay, here delta of UCV equal to what? Equal to C dot delta of UV. Okay, we write it this one. That means if C equal to 0, then not a problem at all. If C equal to 0, then what happens? Then this one equal to delta U CV equal to what? That means orientation of U0 here, U0 equal to what? 0. This one 1 0 equal to 0. Okay, so we assume that. So assume that C not equal to 0. Okay, then we have to show this one. Okay, that means regarding CV as the base of the parallelogram determined by U and CV, then what happened? We also discuss now. So we see that EUCV equal to what? Equal to, we write it, base multiplied by altitude. Okay, equal to what? Equal to, we also discuss in this way. We draw one figure. This one U, this one is CV, this one V. Okay, then what happen is here, that means this one equal to H. Okay, this one, understood? So then base equal, then here C, modulus C length of V. Okay, multiplied by altitude, altitude, and then modulus C, this one equal to what? A of U. Understood? So to easily we also write it, since altitude determined by U and CV is same as that in the parallelogram determined by UV. We write it in this way, since altitude. Okay, since we write in this way, this one altitude. Okay, no, altitude what? Altitude determined by U and CV. U and CV is same as, sorry, U that determined by altitude H of the parallelogram. Altitude H of the parallelogram determined by U and CV. Okay, it's same as that. It's same as that. Okay, in the parallelogram determined by as that in the parallelogram determined by u and v, determined by u and v. Okay, so what happened here, this altitude are same, so we write it in this way, a of uv equal to this one. Okay, so we erase that portion and going to further discussion of that. Here delta ucv equal to what, equal to orientation of ucv, here area of ucv. Okay, equal to what, equal to c by modular mod c, here orientation of uv. Okay, and we write it in this way, this one equal to mod c. Okay, here uv. Okay, not a problem at all. Then what happens that this one equal to c orientation of uv, here area of uv. Okay, that means area of parallelogram with adjacent side uv. Then this one equal to c delta uv. Understood? Not a problem at all. So in this way we also write this one, this one equal to delta ucv equal to c delta of uv. Okay, we also prove this one. So now we're also going to next proof of that. Okay, this proof is, that means similar to this one, we also prove now, that means au plus bw equal to, we also erase that portion and going to discussion another proof. We write it here delta u a au plus bw equal to, here b into delta u of w equal, we also write this one. Then how this one will prove now. Okay, so here was the parallelogram determined by u and w is same as u and u plus w. Okay, because the parallelogram determined by u and w is same as u and u plus w have a common base u and the same altitude. Okay, how we discuss this one, that means if ab equal to 1, okay, then we also discuss this one. Okay, that means how this one happened, we also discuss this one. Okay, this one. Okay, here this one a u w equal to a of u plus w. Okay, then we also do this one easily. Okay, this one obviously we write it in this way because parallelogram determined by this one. We write it here. Parallelogram determined by u and w. Okay, and by u and u plus w. Okay, have a common basis, have a common base u and height. Okay, or height or same altitude. Understood? Then what happened? Then we write it in this way. This one happened. Okay, so we discuss this one. If a equal to 0, then what happened? If a equal to 0, then delta of u here a u plus bw equal to what? Equal to delta u bw. Okay, then this one equal to what? B delta u w. Okay, so this one by first one. Now if a not equal to 0, then what happened? Okay, if a not equal to 0, then what we do? Then we write it in this way. Okay, this one delta u a u plus bw equal to what? Equal to here a common delta u plus u here b by a, this one. Okay, then here a dot delta u by b by a w equal to what? Equal to here b delta u w. Understood? Okay, so then we also prove this one easily. I think not a problem, this one is done. Next we going to discussion about that. Okay, that means we now show another one. We erase that portion and then we now able to show that what here delta u v1 v2 equal to delta u v1 plus delta u v2. Understood? For all u v1 v2 belongs to R square. Okay, then what happen is here, then if u equal to 0, we assume that okay the result is immediate. If u equal to 0, if u equal to 0, then the result is immediate. Okay, here then we assume that u not equal to 0. Assume that u not equal to 0. Okay, then what happen? Choose any vector choose any vector but w belongs to R square, okay, such that uw is linearly independent. uw is linearly independent. Understood? Then what happened? Then we write it in this way. Then for any vector, then for any vector, okay, v1 v2 belongs to R square. There exists scalars ai and bi, okay, ai and bi such that vi equal to aiu plus biw. Understood? Where I equal to 1 2, okay. Thus what happened? Thus delta here u v1 plus v2 equal to delta u v1 equal to what? a1 plus a2u plus v1 plus v2 w. Understood? Then this one equal to what? This one equal to p1 plus p2 here delta uw. Understood? Then what happened? Then this one equal to, we write it in this way, we erase our portion, and then this one equal to what? We write it here. This one equal to delta u a1 u plus b1 w, okay, and plus delta u plus a2 u plus b2 w, okay. Then what happened? Then this one equal to delta u v1 plus delta u v2, okay. So in this way we also discuss this one easily, okay. I think not a problem at all. We also discuss this one easily, okay. Now again we also write it in this way. That means how area, so area of this parallelogram equal to, okay, that means what we obtain now. So the area of the parallelogram, okay, determined by u and v equals, okay, equals what? Equals orientation of uv here auv, okay. This one equal, sorry, not a date of uv, okay. This one equal to a of uv, okay. And we write it in this way. That means this one equal to modulus of date of u, okay. Then what happened? That we write it one example. The area of parallelogram, area of the parallelogram, okay, determined by u equal to -1 5 and p equal to 4 minus 2 is what? here date of uv, okay, equal to modulus of date of here minus 154 minus 2 equal to what, 2 here minus 20 equal to 80. Okay, so I think today we discuss how we find this area of this parallelogram. All are understood this one, and we also that means use some symbol del of uv, a of uv, o of uv. Okay, that means some orientation, area of uv, and del of uv. Okay, this one we also discuss today. So I think all are understood this one easily. Mm, this one is so simple, and we also evaluate this one. Okay, the idea of this parallelogram. So if you get this type of video, please subscribe my channel. If you have any questions, comments, suggestions, write it in comment box. If you want to give like, please click on like options. Today I stop here. Thank you.